The last section in chapter 4 is about isosceles triangles, and we basically already know everything in here, so it's mostly review. When we first learned about isosceles triangles, we know that an isosceles triangle has two congruent sides, and then we also talked about the base angles being congruent, and the base angles are always opposite the congruent sides of the triangle. So the isosceles triangle theorem basically says that if we have two triangles, or if we have a triangle where two sides are congruent, then the opposite angles must also be congruent. So if this is true in this triangle, these two sides are congruent, then these angles are also congruent. The converse of this is also true. Converse means that you can say the sentence the other way around. So if we have a triangle and we know that two angles are congruent, then the opposite sides must also be congruent. So in the triangle pictured, if we know that those two bottom angles are congruent, then the two sides opposite those must also be congruent. There are a couple of corollaries that go along with the isosceles triangle theorem. The first one says that, and this is something that we already know from 4.1, a triangle is equilateral if and only if it is equiangular. Now this is related to the isosceles triangle theorem because the isosceles triangle theorem said when we have a triangle and two sides are congruent, then the angles opposite those sides must be congruent. Well, in equilateral triangle, we just have a third congruent side, so that third angle is also congruent to the other two. And then we also know if the angles need to add to 180 in a triangle, if we have three equal angles, then they must be 60 degrees each in order to get the 180. So each angle in an equilateral triangle is 60 degrees. In this example, we have two isosceles triangles that are sharing a side. The triangle on the left has the two congruent sides marked, and then the triangle on the right has two other sides marked. So this side here, that's not one of the congruent sides on the triangle on the right. It's these other two that are congruent. And all we know is that one of those angles in that triangle is 55 degrees, and we don't know anything else. But we can find angles 1 and 2 by first finding the all of the angles in the triangle on the right. So since we have the two congruent sides in that triangle, we know that the opposite angles are also congruent. And so if we call those angles x, then we can say that 2x plus 55 equals 180. And so that gives us, the angles are each 62.5 degrees. So I will just mark that over here. Now, that 62.5 degree angle and angle 1 are linear pair, so they must add to 180 degrees. So we can say 62.5 plus the measure of angle 1 is equal to 180. And that gives us an angle of 117.5. So now in the triangle on the left, 117.5 is the vertex angle. That's the one that's not congruent to the other two. Angle 2 and this angle over here are the base angles. These are the congruent ones. So let's say I call them both y. Then I can say that 2y plus 117.5 equals 180. And that gives us that y is equal to 31.25, which is the measure of angle 2.